Thank you all for joining Climate Work Maine. This is our second out of three sessions in our annual Autumn Climate Connection Business Webinar Series. My name is Jeff Marks. I'm Climate Work Maine's Executive Director and today's moderator for the session. For those of you who don't know Climate Work Maine, we're really businesses and organizations of all sizes and types that provide services and networking to and support companies with products, services, programs, projects related to climate solutions, and to support and assist those who want to do more on climate action. Really, we connect businesses to the resources that they need to grow and succeed in a sustainable economy. I'd like to start by thanking Drummond Woodsum for sponsoring this year's webinar series, which focuses on Maine's energy dominance across renewable energy, other alternative energy sources, which we'll talk about today, energy efficiency, and grid infrastructure. Our events are supported by our members, including our heroes like Bangor Savings Bank, CMP, Hannaford, and Unum, all very familiar companies to most Mainers. Switching over, today's session is entitled Not Another Solar and Wind Webinar, Other Alternative Energy Resources for Maine. I say not another solar and wind webinar because we hear a lot about both of those energy resources, both very important to the environmental, energy, and economic future of the state. But we wanted to kind of give high-level overviews of what else is going on in Maine. And to do that, we have 5 participants today. And when I say high level, they are going to give very high level overviews, and we may dig deeper into each of these in future events. But we have Jeremy Akers today from Castle Rock Biofuels, Jim Van Valkenburg with Froling Energy, and they are a wood pellet company. Lizzie Reinhold, president of Peaks Renewables, who will be talking about reformulated natural gas, renewable natural gas. Steve Zaretti with Brookfield Renewable, which of course is a hydro company, but they're involved in a lot of different renewable energy projects around the country. And Brooke Morrison, who's with Solstice, and she'll be talking future of nuclear, which is on everybody's minds these days. We urge you to ask questions. Please do that using the question link on the bottom of your Zoom screen. I do want to thank Jen Brooks for producing our webinar and make sure that you all see and hear our experts and are able to ask questions. And with that, I'm going to turn it right over to Jeremy to kick us off.
All right. Appreciate it, Jeff. Many thanks to you and Jen and the Climate Work Maine team for bringing this conversation together. I'll do my best to keep it high level, but I do tend to get into the weeds, so I'll do my best here. But my name is Jeremy Akers. I'm with Castle Rock Biofuels, and I'll start by saying that large Maine facilities burn millions of gallons of fossil heating oil each year, and decarbonizing that heat in Maine should use Maine resources. We convert local forest residues into a renewable fuel that displace fossil oils. So who are we and what are we actually building? We're developing a facility in Millinocket on a greenfield parcel within the former Great Northern Paper Mill site, and we'll produce 20 million gallons per year of renewable fuel oil from approximately 300,000 green tons of forest residue. Specifically, that's slash from conventional timber harvests. We're a joint venture with Ensign Corporation. We're using their commercial RTP fast pyrolysis technology. It's been used at commercial scale in Canada for about 30 years. The reactors we're building are roughly the same size as the reactors at a sister facility in Côte-Nord, Quebec. At full operations, we expect about 80 on-site full-time roles, and our target for the facility to be in service is mid-2028. At a high level, the front end of the plant has wood handling equipment. It looks similar to a traditional mill, and the back end of the plant is more similar to a chemicals facility. The feedstock that we use, forest residues, are received chipped. Material is then sorted, further sized and dried, and it's thermally converted via pyrolysis process in a matter of seconds. And while we optimize the process to create oil, syngas and biochar are also created, but they're recycled back into the system to provide process heat. The plant operates in energy balance, and it's pretty quite elegant. So our business really starts with the feedstock that we use. We source forest biomass residues by working directly with landowners, forest managers, loggers, and contractors. Critically, our feedstock is generated only when timber is harvested for higher value products. We're using the limbs, tops, branches that are typically left to decay or managed via pile burns on site. Our forestry consultant there in Maine is Eric Kingsley of INRS. He prepared a sustainable feedstock plan that was approved by the EPA, and his supply chain analysis indicates we should see roughly 90 plus jobs across the forestry and transportation sectors tied to utilizing this residue. On the customer side of things, our primary customers are large institutional industrial thermal users. These are colleges and universities, hospital, healthcare campuses, and district energy systems. These are clients that are often burning over 1 million gallons per year of traditional heating oil today. So to them, we provide a low carbon, locally sourced fuel with price parity via long-term supply agreements without curtailment risk. And it's a pathway to rapid emissions reduction without wholesale boiler replacement. Typical site work involves burner tip upgrades, pumping, heating skid, and storage handling, generally scaled to a facility's load and storage preferences. Obviously, we're talking about benefits for Maine, and economically, our project will support about 200 construction jobs during the build out. As I mentioned, 80 full-time roles on site once fully scaled out, and roughly 90 plus supply chain jobs in the forestry and transportation sector. We've already done an independent life cycle analysis for the RFO, our fuel oil. It came in at 4.34. That is from the harvest of the material to our gate. That's roughly on the order of 90% lower than conventional heating oils. A big part of that, and you'll hear from Stevens already later on in the meeting, but a big part of that is that the old paper mill sites are not connected to the grid, and one of the reasons our product has such low carbon intensity score is because we source our power directly from Brookfield's hydroelectric resources. I'd say that factor is key to the continued development of the former paper mill sites. The forestry industry is a big part of Maine's story. Our participation in the industry supports the entire supply chain and contributes to sustainable forestry silviculture. And then in some parts of the country, not so much Maine, it does support wildfire risk mitigation. Obviously, that contributes to energy independence. We use a renewable non-food source waste product to replace traditional fossil-based heating oils. Obviously, for where we're building, that strengthens rural economies with job creation, skill training, and again, we're producing a low carbon fuel that powers growth. So we were asked to touch on challenges, and I think any project of this size certainly has its share. We've been fortunate to work with a number of really great businesses and leaders in Maine that have helped us overcome hurdles, and we will continue to do so. Just touching on a couple of these challenges, I'd note first, feedstock market structure. The sale of biomass in Maine has historically been a spot market, but our investors, need us to execute supply agreements. They need to understand who'll be supplying the feedstock and at what price. It's an area of risk. Any risk impacts our cost of capital. So the general harvest of biomass and inwoods shipping capacity has declined over the past 15 years. And we need to work with our forestry partners to make sure that technology and capacity is in place to supply the volume of material that we need. Second, I realize it'll be a couple of years before we're fully in service, but much like the feedstock conversations, we need to identify local demand for the product now. And because there's a conversion capex with somebody converting to use this fuel, that's upfront boiler and fuel handling upgrades, the process of getting to supply agreements can be a lengthy one. We can tackle that conversion with long-term supply certainty, customer-friendly financing, and where available, policy tools that'll recognize emissions and in-state economic benefits. Finally, I'll note we've had some challenges getting to a final form with an EPC. We were working with a Canadian firm that has experience in building these facilities, and they produced our initial front-end engineering work and design. But with tariff talk, cross-border challenges, it would have been difficult for that firm to bond the project. So we pivoted to running a process and selecting a US-based EPC. It's taken extra time. It's delayed the project a little bit, but we're confident that we're going to have an excellent engineering partner to help build it out once we get going. On the federal level, we operate underneath the Renewable Fuel Standard Law. It's a bipartisan law from 2007, governs renewable fuels in the US. Every gallon of fuel that's burned of ours generates a D7 RIN credit that obligated parties must buy to offset their fossil-based emissions. Our EPA approved feedstock plan defines the eligible material that we use, and we have to provide robust compliance monitoring to track origin, volumes, chain of custody of the material that we use. I'll note sometimes there's a gap between how the EPA defines eligible wood for the RFS and then how the US Forest Service uses wood and its definition in silviculture and residue management context. For us, we support continued alignment and clarity so that true residues, including cull logs, but not saw logs or high value material, are clearly recognized and encouraged for low carbon fuels. The clarity helps landowners and us plan residue handling and compliance. So one key federal request that we have is to explicitly authorize renewable fuel oil for industrial process heat, not just human comfort heat. It's the same fuel, same types of boilers, displacing the same fossil heating oils, and it decarbonizes the most energy intensive thermal loads in manufacturing. Recognizing process heat as an eligible pathway into the RFS, I think would unlock meaningful emissions. At the state level, definition and eligible clarity, there are a lot of conversations around basically modern wood heat in Maine and using renewable bio oil that's sourced from forest residue to qualify along modern wood heat would help in public procurement process. And I think grant or low-cost financing for one-time conversion scope, burner tips, nozzles, controls, storage handling, that targeted support would unlock long-term supply. And another accelerator is just public anchor procurement, encouraging multi-year offtakes by state or quasi-public institutions. That long-term tenor and demand lowers our capital cost, shortens the path to decarbonization. And I'd say a fourth ask would be to help us work through the regulatory process with Brookfield and New England ISO to ensure that the former paper mill sites can be supplied by the hydroelectric power as intended. I'll wrap while I still have the floor with a couple call to actions. If you're a large heat user in Maine, let's talk. Obviously, we want to make sure that the people who use this type of fuel know that we're building. If you're a policymaker, a program administrator, clarity on and eligibility and support for conversion CapEx, that will move real material, real jobs, real local spend. And if you're a regional partner in workforce or infrastructure, we'd love to collaborate in Millinocket. Together, we can decarbonize heat, strengthen forest economy, and support the local economy. So happy to answer questions and dig into any of these areas. I know I covered a lot, but get into it in the Q&A. Thanks for the opportunity to present.
Appreciate that, especially since I was born and raised in East Millinocket, and I'm always interested in companies who are looking to come up and help with economic development. And I'm glad you have that hat.
Just got to support the guys there. They're doing tremendous work at the site, bringing in businesses to this location. And East Millinocket was under consideration as well. This ended up being the right location for us as a greenfield. But yeah, it's been they've been a good partner in helping to develop that site.
Thanks, Jeremy. Jim, you're up.
Okay. You should be able to see my screen here. Okay. Well, I'd like to thank you for inviting Froling Energy to be a part of this. We're a contractor, a mechanical contractor that does a lot of work with what we think are big clients. I think Jeremy's got even bigger clients, but our clients tend to be both schools and some industrial settings, and hospitals and things or nursing homes and things of that scale. And the typical usage, instead of the million-gallon range, we're somewhere around 30,000 to 150, 200,000 gallons of oil used a year for heating. So it's that sort of middle market scale that my company really works in. And so I'd like to make the case here of just making sure. Just one second here. There we go. Okay, I want to make sure that that wood of this nature, which is wood chips and wood pellets, makes its way further into the main energy landscape. And one of the good reasons is that 89% of the state is covered with forest. That's about 17.5 million acres. And it is, by percentage, it is the most forested state in the United States. So Frolin Energy, a mechanical contractor, we've been focused on biomass boiler systems since the beginning. Our offices are in Keene, New Hampshire. We've done a tremendous amount of work in New Hampshire and Vermont, renovating boiler rooms essentially in a lot of schools and a lot of other facilities. And we're also working now in Maine. Most of our installations are in the big old buildings, the schools and commercial structures. They're using lots of oil, lots of fuel, because the building itself is difficult to insulate. It's difficult to electrify. Imagine the electric load should these buildings be totally electrified. So it's a more practical thing. They often have end-of-life boilers. That's usually the stimulus to do something. And they've got steam or hot water distribution systems that are still viable and can be reused. Decarbonization is a big word in the industry these days. I talk to a lot of engineers and they see, well, companies are calling them up. We got to decarbonize. We've got this goal. We've got to make it. And this is certainly one way to do it, is a fuel switch. There's a lot of other strategies that you got to build in if you're running a business, but this is pretty important. And here's a good example: Maplewood Nursing Home. It's in Western New Hampshire here. And it is a typical nursing home, big old place that has central heat. They were burning 81,000 gallons, actually more than that. They did some renovation and some changes and reduced it down to the 81,000. And now the savings are tremendous. In fact, because of a price hike in oil, they paid for this system within about 6 years. So the price hike in oil, what we didn't have to pay at the $4 range, much better. And you can even see the CO2 reduction, which was not their primary goal, but it certainly is a good add-on for them. And Wheelan Engineering is another big place, 500,000 square foot manufacturing. They were burning a tremendous amount of oil, 150,000 gallons plus, and they had some problems on site with their oil tanks. And they said, "We're just going to get off of oil," and they switched to dried wood chips. This is a multi-building campus. You can see it's a fairly big space here, and now it's a district heating system as well. And they're saving this tremendous oil. Basically, you know what oil's selling for. It's up and down all the time. Well, here we're providing dried wood chips at a cost of about $1.20 a gallon. So that's tremendous savings for these people. Now, picture a logging company working in the Maine woods. They're looking for logs for lumber and furniture. Those bring the highest profits. At the same time, the foresters are thinning and doing selective cutting with them. I should say they're forester assisted. And they're also fostering the growth of the higher grade trees and boosting the health of the forest overall. And thinnings are the result. And those thinnings and logs are loaded up and hauled away by local truckers. They're building, everybody knows that building with wood is good. These days, they're building wooden skyscrapers and things like that. But there's a lot of waste at the lumber mill. And I wonder if you're aware that 30% of a log that goes through a sawmill turns into waste. It's round, turning into rectangles. So that's one of the reasons there. But there's multiple wood pellet plants in Maine that are using this wood waste to turn into pellets. And that waste, again, with the forest thinnings, they're also using sawdust and chips from sawmills and wood product manufacturers. So they combine all of this into those pellets. And again, one of the best reasons to switch to wood is economics. It's not only for the buyer, but it's also for the general society here. You've got a much more stable price on the wood fuels. Wood just doesn't rise and fall. It does a little bit with oil, but not as much as oil, and other fuels are skyrocket and then come back down again. It's much more stable. With wood, nearly all the money involved in heating a building actually stays local. So the wood source local, the manpower to gather and deliver it's local, the use is local, everything's great for the economy. In comparison, say oil just doesn't leave that much money behind in the local economy. So we're part of the carbon cycle, that old cycle that everybody knows about. The trees take the CO2 and turn it into wood and so forth, and then when you burn it, it turns back into CO2, and this circle goes round and round. And we like to point out that fossil fuel is basically a one-way street from a million years ago. The carbon goes up, and there it is up in the atmosphere. So that cycle really it's an important player within the whole idea of that we're renewable. Now, there's obstacles. One of the things is those old wood stoves, the public perception of, I don't want that smoky wood thing, whatever it is, whatever scale it is, it just seems to have a bad rap. But I got to tell you that the new systems are incredibly efficient. We put in these orange boilers. This is the Schmid boiler. It's a European, very high-tech boiler, and we don't have to put any kind of scrubbers in this system at all. It is tremendously efficient in both particles as well as general emissions. So we find that if you're thinking about the latest technology, you've got the right idea. And it's certainly on par with some of the most efficient oil systems that you find today. This is an example of a brand new, the Margaret Chase Smith Community School up in Skowhegan, just built, and has a big Schmid boiler in there, 3 million BTUs to cover the heat for this school. And it's using wood pellets that are produced locally. So it was just fired up, and it's going to be its first winter this winter right now. The U.S. Department of Agriculture has grants for wood system feasibility studies and for system installations. That's federal, but there's no other federal tax credits or rebates on the commercial or even residential scale at these days. Efficiency Maine does have residential and commercial rebates and grants as well, and those are things to certainly look into. They're very friendly with the wood fuels, and they have a lot to offer there. Wood fuel users also are able to generate income by generating and selling Maine thermal RECs. A renewable energy certificate, can be sold on the marketplace for, you generate these by using wood fuels and by actually monitoring the amount of heat that you're generating very specifically in BTU meters. But that's a good way to support the transition into using wood. So it's very cost effective by doing this. So we just say modern wood chip and boiler technology is able to replace the existing oil-fired systems as they are, and they're readily available. These fuels are readily available in Maine, whether it's wood chips or pellets. They're highly cost effective for those big old buildings and for new ones. And we ask, what are we waiting for? That's it.
Thank you, Jim. We've talked a bit about one of our heritage industries, the forestry one, but Lizzie, your company has a great story. You're working with farmers in the agricultural sector, so looking forward to your remarks.
Yeah, absolutely. Lizzie Reinhold, I am president of Peaks Renewables, and we are a renewable molecule company. So a lot of folks focus on decarbonizing electrons, but we know that molecules are nature's form of energy storage. And with that, just as we've decarbonized the wires that flow above us, we're focused on how we decarbonize the molecules in the pipes that run below us. And you can do that by utilizing waste products. So for us, we really focus on turning sort of one man's trash into another man's treasure. Every day, you have individuals who produce about 5 pounds of municipal solid waste a day. You have dairy cows that produce between 100 to 150 pounds of manure if they're lactating a day. And all of that ends up getting you know, emitted into the atmosphere in the form of methane as it decomposes. For us, we focus on capturing that methane and turning it into renewable natural gas. In addition, we create a variety of waste products. So you have the renewable gas, you end up having a solid that can be used as animal bedding or turned into a biochar product. You also ultimately have a liquid which can be used as a fertilizer and reapplied to land. So in Maine, we have a project that's a community dairy digester in Clinton, Maine. That community dairy digester works with 6 family-owned farms. We bring the manure to one central farm at Flood Brothers Farm, the largest dairy farm in the state of Maine. And we capture that manure and turn it into methane, about 130,000 MMBTU a year, which then gets put into gas pipelines on Summit Natural Gas of Maine system, and it flows to homes and businesses throughout the state to warm them. Ultimately, we end up selling the renewable attribute on the renewable fuels market, which is a transportation market that's used to decarbonize vehicles. For us, though, we don't stop at dairy manure. Peaks is really focused on any type of feedstock that can sort of turn waste into energy. So be it landfills, poultry litter, feedlots, food waste, etc. We recently invested in a landfill project in another part of the country that's taking landfill gas and turning it into pipeline quality gas. And then we also are working on a variety of poultry litter projects in Arkansas and Oklahoma, where we take poultry litter and not only turn that into a renewable gas, but also an organic fertilizer to be able to be sold on the market and used to grow vegetables and other crops. For us, the focus is really on the fact that we're not going to stop having waste, right? Humans aren't gonna stop eating food. We're not going to stop creating trash. Cows aren't going to stop producing manure. And so for us, this is really the story of resourcefulness. Waste is always going to happen, but the real tragedy is having waste happen and not then utilizing one of the most precious resources it creates, which is a form of energy that can be used to fuel industry and warm homes. Particularly as we think about increased demands on all of our energy systems, whether it's electric generation or gas generation. Across the country, a lot of renewable gas projects ultimately produce electricity. That was a trend leading up until 2015. And now the pivot has really been to actually clean that gas up and create a pipeline quality methane that can be put into our pipeline system, really helping push forward energy dominance and local gas production. For us in Maine, when we think about it, we're an extremely gas constrained region. And we see that. I worked for years on the utility side at Summit Natural Gas of Maine, where we would see extreme price spikes in the middle of winter because of the gas constraint coming into New England. To be able to have a locally sourced energy source on our system really helps buffer against those price spikes and add a certain system of reliability and resiliency. We also, Summit Utilities, who's our parent company, they operate a large gas utility in Arkansas. And in Arkansas, we experienced extreme freezing events during Winter Storm Uri, and we had a lot of gas supply constraint issues. The landfill project on our system in Fort Smith, Arkansas, producing renewable natural gas, was actually one of our most reliable sources of gas at that time, because unlike sort of the freezing we would see, we were able to get that gas locally sourced on our system. So being able to increase sort of the diversified resource of being able to get those molecules is really important. When I think of challenges, though, I think of how much energy we've put in, not just in Maine, but across the country into decarbonizing our electrons. We have, renewable portfolio standards. We've created a plethora of policy and regulatory frameworks to be able to decarbonize those electrons. And we need that same type of framework to decarbonize molecules and advance these projects in their development. The American Gas Association recently did a study and estimates that there's enough feedstock potential to be able to meet all residential demand of natural gas with renewable natural gas. The question is, can we develop it? Can we build it? And can we create the markets to be able to do that? And that's where we really stand at this cusp and challenge today. both in Maine and outside of Maine. On the utility side, there's always this question of how are you going to decarbonize your gas system? Well, we have the answer. It's decarbonized molecules like renewable gas or green hydrogen or a blending of the two of them. The question is, are we going to create the regulatory framework to be able to do that? Are we going to create the policies that enable us to even bring those renewable molecules onto our system? Today, we can purchase the gas itself, but we aren't able to purchase the actual renewable attribute and credit to go along with that. And I think that's one thing that has to change. The other thing that's really happening today is that there's a global conversation around renewable molecules. So there's a major focus on decarbonizing the maritime sector worldwide. The EU has moved forward with emissions reduction goals. There's a lot of conversation at the International Maritime Organization around that. So I sit on the board of the American Biogas Council, and a huge focus for us is how do we work with other regions around the entire world to take what has been a pretty domestic product and take it global. So what you're going to end up seeing if we don't create the frameworks to utilize this renewable resource here at home is going to see these resources being exported elsewhere. So the development will occur. It'll just occur and someone else will be taking advantage of the benefit of it. So that is our work in a nutshell. It's what I love about it is the fact that not only are we creating a renewable resource, but we're supporting the agricultural community at the same time. We're supporting family farmers. We're supporting, chicken farmers. We're finding resources to not just take, food waste and turn it into a renewable gas, but then we're also turning it into a fertilizer that can be used to then grow additional crops. And that's the most exciting part of the work to be able to do, to be able to drive investment in rural economies, create jobs, create an energy resource, and give back to the real heritage industries that have been supporting those economies for generations.
We appreciate that, and you brought it around full circle on where I started when I introduced you, that impact on local farmers and what you bring to them in that industry. We're going to move on to Steve, who's going to be talking primarily about hydro. I don't know if everyone in Maine is aware that I think it's 27% of electricity produced in Maine is hydro. Steve, you can correct me on my stats, but I'll turn it over to you.
Great, thanks. So Steve Zaretti with Brookfield Renewable. I've been with Brookfield for just over 10 years. My current responsibilities are largely commercial contracting. So think of long-term power purchase agreements, opportunities for bilateral conversations and arrangements with organizations like Jeremy's, and then also for policy market design and development. So I'll start with a really brief overview of Brookfield in Maine specifically, talk a bit generally about hydro in the state, and then some of the challenges and opportunities. So for Brookfield in the state, we've been in Maine for over 20 years now. Our current portfolio includes over 600 megawatts of hydro, and we have 3 operating battery storage projects in the state as well. And then through affiliate companies, we own and operate over 200 megawatts of wind and a number of solar facilities. So quite a diverse company in Maine, and then throughout the country and globally. Just starting with a general view of hydro in the state. So obviously Maine's history is very closely connected to hydropower. You have many facilities that were built over 100 years ago, and they're still operating in and around the communities that they initially were built in and around. And then in most cases, you got facilities that have been operating for at least several decades. So hydro is critical to Maine's energy mix. And I think, Jeff, you got that right. Giving a sense, annual production on hydro contributes about a quarter of all energy production in the state, and that's on an actual megawatt hour basis. If you compare that on the basis of renewable energy production, hydro is about 2/3 of renewable production in Maine currently. In addition to just that production capacity, it's really the generation shape and the availability and even the flexibility of hydro that makes it a particularly unique and necessary resource. So you have these overlapping benefits in terms of a clean, renewable, stable resource with some flexibility within the hydro fleet that then provides sort of a necessary complement to intermittent renewables on the system. And then from a state policy perspective, hydro is relied on heavily to meet Maine's renewable portfolio standard requirements. So it's the largest component of the Class 2 market, which is really the existing renewables tier of that RPS. And then a number of hydro resources even support the Class 1 requirements as well. So an important contributor both to Maine energy mix as well as to Maine's policy aims. And then just touching briefly on challenges for hydro, I think it comes down to really regulatory challenges, policy limitations, and then general overall transmission system constraints. So from a regulatory perspective, what is most notable, and I think most unique to hydro, is the licensing process. So you have licenses that are issued for a period of 30 years or more. But when that license expires and you need to obtain a new license, it's often a 5 to even 7-year process. There's a lot of stakeholder input. There's a lot of regulatory agency involvement at the federal and at the state level, a lot of studies required, a lot of trade-offs, and ultimately a lot of costs to the facility. So it's complex and it's increasingly uncertain within the state of Maine. And we've seen challenges from this process play out most recently on the Kennebec River. I know that's received a lot of attention in the local media. In that case and elsewhere, the state is conditioning these licenses with extremely expensive requirements in terms of CapEx requirements, as well as the potential for lost energy production, and then including challenging or unmeetable standards for those licenses. So the process generally is a challenge, and you actually have a lot of resources in Maine that are currently seeking new licenses or will soon have to pursue those licenses. So it's definitely going to continue to be a conversation. In terms of policy challenges, as I mentioned, Maine does promote hydro participation in the RPS. However, the market that most hydro participates in, which is the Class 2 market that I mentioned, it has a price cap, and that price cap isn't aligned with other similar markets in the region. So that price cap has the effect of limiting revenues available to resources that participate, but at the same time, it can have an impact on the supply of RECs available to that market. So as resources sell their attributes to other markets where they can qualify and obtain a higher price for that same attribute, what it creates is limitations to Maine's ability to meet its own policy goals. And then lastly, and just highlight the transmission constraints and some of the related congestion and curtailment that corresponds to that. It's not just a hydro issue, it's really an issue for many resources and kind of all resource types in Maine. But at a high level, there are limitations on the existing transmission system. And as more and more resources come online through state-sponsored programs and out-of-market contracts, it means that resources are more exposed to the potential for curtailment and even exposure to negative pricing. So you can have significant impacts on a facility in terms of reducing its revenue or even being charged for generation during hours as opposed to being paid to deliver. So absent more investment in the transmission system, more holistic planning and procurement, you actually run the risk of new contracted renewables displacing existing renewables. And so there's this counterproductive effect and impact on policy achievement, and of course, ultimately potential risks to resource retention and resource reinvestment. But as much as there's challenges to navigate, we are in a moment that I think presents a lot of opportunities for the existing fleet of hydros. For one, there's just a lot of challenges to building new resources, whether it's siting or interconnection or impacts on supply chains. And then, of course, most recently, pullbacks in policy support at the federal level. Just a lot of ultimately headwinds to new builds. So what that means, I think, is that we need to take stock of the resources that we actually do have available. And that really presents an opportunity for existing and reliable resources like hydro. And we're actually seeing buyers reevaluating the role of hydro in their portfolios or in their sustainability stories. So there's currently a lot of interest in long-term contracting for Maine hydropower facilities. That includes from entities like publicly owned utilities within the region or even voluntary corporate buyers. There's also, I think, an opportunity here to consider policy adjustments that more appropriately promote resource retention. And that can mean incorporating hydro on a more level playing field to other resources within the context of the state RPS. And then there's, I think, more specific examples like what Jeremy discussed. So we're really excited to partner with Castle Rock and others in Millinocket and East Millinocket. There's an opportunity there to utilize our resources to support operations and related economic development. These are meaningful opportunities. They're sustainable, they make sense for the region, and they're for the long term. So it's great for hydro to be part of that story, particularly at those sites, to sort of reimagine what those sites are capable of, but the legacy element of using these hydros that once powered them. So I think there's a lot of opportunities. There's a lot of new ways to think about hydro and its role in the energy system. But I'll leave it there, and certainly glad to discuss more questions as they come up.
Thanks, Steve. For all of you in the audience, keep your questions coming. When we finish up with the presentations, we'll go right into your questions. But for now, let's talk about something completely different. I think there's been more conversation about nuclear in the last 8 months than I've heard in the last decade. And we have Brooke from Solstice, who can talk a little bit about what she's hearing and seeing and what she's working on. So Brooke, over to you.
Yeah, thanks, Jeff. It's great to be here with so many people I think that care very deeply about Maine's future. I am the founder and CEO of a company named Solstice and a mother of 4 here. I care very deeply about the future of not just our environment here, but the well-being of our communities and, of course, our long-term sustainability of the state. One of the things that I love to tell people is that here in Maine, we are so proud of our independence, and that's part of our identity. And yet we are a state that is more dependent on other states and another country for baseload energy than almost any other state in the country. And while we have done an incredible job by producing or using renewable resources, hydro, wind, solar, biomass to create electricity in state, the reality is when you look at our total energy use, not just electricity, the picture changes dramatically. More than 60% of the energy that we are consuming in Maine is coming from fossil fuels, and that is our baseload energy. So as we electrify and we create power stations for electric vehicles, as we are continue to expand heat pumps into residential places, as we look ahead at a lot of economic development across the state, it all requires baseload energy. And what that means is energy that is going to be reliable 24/7. And right now we have 2 real options for that. One is fossil fuels and the other is nuclear power. And Maine has a very rich history in nuclear power, having been one of the few states that had a large-scale nuclear power plant in Wiscasset. Part of what we do at Solstice is we go into communities and we are paid either by states, local businesses, and partnering actually with companies that are designing the newest and latest nuclear reactors. And we try to understand what all of the stakeholder needs are, what their concerns are, and we address those. Maine is a very unique state right now, where it's one of the few places in the country where it's illegal for us to really have this conversation in a meaningful way. And the reason for that is back when we shut down Maine Yankee in 1987, we had very little operating history at the time that made a lot of stakeholders feel very comfortable with the idea that nuclear energy was safe. We had very limited options for something that we called nuclear waste at the time, that right now we recognize is actually fuel for our future fleet globally of nuclear power plants. Our company right now is primarily working in Canada to develop new nuclear power plants. And I find that to be a great irony, because in Canada about 5 years ago, we had to whisper the word nuclear. And here we are in the state of Maine, where right across the border, we are building nuclear power plants. And we import energy that is interconnected with hydropower coming from electrical lines just north of the border. And a lot of people in Maine don't understand that. So when people are concerned about Well, what about the waste? Well, what about accidents? There's so many misconceptions around that. And unfortunately, it's 7 minutes. There's no way for me to go through a lot of, adjusting, I would say, those misconceptions, except for the fact that globally right now, we are getting so much smarter about how we can use this technology to support and complement all of the other technologies that were just talked about. Right now, 50 years after we made the decision in the state of Maine to create a legislative position where we would not be really studying, having deep conversations or meaningful conversations about nuclear power, nuclear technology has advanced dramatically. And Maine, as a lot of people say, well, we have a decentralized population, so having a nuclear power plant doesn't really make a lot of sense. The reality is Maine actually spends more money per capita on importing our energy, both from New England ISO and from the state and from the country of Canada, than any other state in New England and comparably to most of the United States. And another irony is that, when I started this company, we were decommissioning at the time Vermont Yankee, and I was looking at all of the impacts socially to the state, and they were dramatic. The impact on schools, on healthcare, on all of the basic services that people wanted. No one really talked about the fact of the interconnection of losing the baseload power and the jobs and all of the tax base that came from the nuclear power plant that people now recognize are absolutely critical for a state if they want to have sovereignty to be able to achieve that goal. So as we look at the long-term sustainability of Maine, it's impossible to not look at baseload power. And in order to do that today, we have to start with changing the law. It was a few short months ago where the issue came up. I can tell you that the conversations around it were, I would say, pretty meaningless from a technical perspective. They were very short, and most stakeholders and residents in the state had no idea that this was even happening, nor did they understand the implications relative to the tax base of the entire state and the cost of their energy. Right now, we are looking at the cost of energy almost doubling for the state of Maine. And it's a trend that's happening across the country, and it's happening globally because of electrification. But we are one of the few states that we are not really looking at the full suite of options available to us. When we talk about paper mills, when we talk about food processing centers, when we talk about, once again, the social programs, nuclear energy is one of the cleanest energies that we have available to us. And right now, we are making a very conscious decision in the state of Maine to use fossil fuels over nuclear power. There's a lot of stuff in the policy arena that it would take at least an hour to try to get into how we got to where we are and what it would take to make policy change in this state. Would love to have further conversations about that. One of the number one assets that I would say that we have in this state is not just a site that used to have a nuclear power plant, but it's connected to the grid. And what that means is, we get to look at the full suite of technology, of nuclear technology that's out there and try to figure out what makes the most sense. In an innovation park in Wiscasset, Maine, that included renewable energies alongside of new nuclear technology would create an incredible wealth of tax base for us to become not a net importer of energy, but a net exporter of energy. New England is facing an energy shortage that is one of the greatest in the entire country. So we don't have to look very far for where our customers would be if we decided that we wanted to create enough energy to export it. And what it would do is it would make us a lot less reliant on Washington, D.C. and other countries like tariffs that would impact the price of our energy. The reality is there's a lot of people that have influence over what our baseload energy is, and they get to vote on that when they only live here 3 months of the year. And those 3 months of the year, you can open your windows and you have a lot of options in terms of how you're going to make it through the summer in Maine. the reality is in the wintertime, the people that are residents year round are the ones that suffer the most in terms of cost, in terms of not being able to have access to a lot of social programs that right now are underfunded. And one of the things that we are very passionate about within Solstice is trying to link together how we can support the social and sustainability goals of a community and a state with their baseload energy. I realize that doesn't get very technical, but I'm going to stop there and let everyone start getting into questions. Thank you.
Thanks, Brooke. I appreciate that. And to all of you, I was a little nervous about this panel because I knew the content was going to be awesome, but you all covered the issues that we talked about, such as benefits of that particular energy resource, the challenges, and the impact of state and federal policy on these issues. So thank you. We all did it within 50 minutes, which is what we expected to do. We have about 8 minutes for questions, which I know is not enough time, but like I said at the onset of this session, this is just the beginning of the conversation, and we'll dive into these topics a little bit deeper in future events that we do. But Brooke, I'm going to start with you. Nuclear's had a bad rap in Maine. You talked about that. It's clearly having a big moment right now, especially in federal discussions. What's the difference today about nuclear energy, and how has the industry addressed various stakeholder concerns over the years, especially in Maine?
Excellent question. I would say the number one question that we get is, what about the waste? And that's one of the areas there's so many misconceptions about that. We could get into the demand side. That's going to be a little bit more complicated, but let's just say demand has increased dramatically for energy overall because of electrification. But on the waste side of things, most people don't recognize that nuclear waste is it's a policy definition. And we are one of the few countries in the world that decided for national security purposes that nuclear waste was going to be called waste as opposed to fuel. And the reality is there are a lot of byproducts that are currently sitting in Wiscasset, Maine, which would cover altogether over 23 years of operational history, one football field about 6 feet deep. That's fuel that is currently being explored by the U.S. Department of Energy and a lot of private entities across the country for reprocessing. And reprocessing is the heart of a lot of countries' policies that have nuclear energy as their baseload energy. So big topic, lots of technical aspects of what goes into that, but the rest of the country is looking at waste as something, nuclear waste as something that will be used in the future as a fuel, not a byproduct.
Good, thanks. Jeremy, I watched the questions come in, and this one came in while you were speaking. Can you speak to the cost, the price of biofuels and what's expected?
Sure. In simple terms, we can price our fuel at parity with and beat traditional fuel oils. And depending on the transportation distance and a couple other factors, get close to parity with nat gas. When we look at the total value of our product, obviously we have our cost of production, but then from the revenue side of things for us, there are, as Jim mentioned, the T-Rex in Maine, you have the D7 RINs. So those are considered environmental attributes. And then to the client, there's the cost of the fuel itself. And we try and make this, switch over to our fuel as painless as possible. So really offering at parity to, the other fuels that they would be using.
Okay, thanks. A couple of climate emission focused questions have come in. Jeremy and Jim, this is primarily for you. Can you discuss a little bit the carbon footprint of biomass, biofuels versus some of the other non-fossil fuel solutions like solar, hydro, even nuclear possibly?
think the best thing to say is that we use this idea of biogenic carbon versus the kind of carbon that comes out of the ground. And you know, the fact that there's a tremendous amount of fossil fuel carbon in the atmosphere that continues to come all the time. And we're trying to take little pieces away from that, just one building at a time. And we're using this local fuel that's definitely a waste stream product. And so but I will say this, if you put a carbon detector on our chimney on any one of our sites, you're going to get a good amount of carbon coming out of it, almost about the same as what the like an oil boiler would be. But it's that source of the carbon, just what we're doing to process it, the locality of it and so forth. Maybe Jeremy can speak to that a bit more.
Yeah, no, I think you actually you did really nail it. And I think Lizzie spoke to this as well, but biogenic carbon is considered a zero carbon source because much like the waste from her process, biogenic carbon would be released into the atmosphere whether we did anything with it or not. Right? The wood that we'd be using would be left on the ground. It would decay, it would decarbonize. If it gets wet, it's releasing methane. And, so that material would be impacting the environment as it would in general. It sequesters the carbon as the tree grows. And then as it is left on the ground after a harvest, that biogenic carbon at the federal regulatory level and by science in general is considered a zero. So I can't speak to the other fuels out there or other resources, but for what we do, that's how it's calculated.
Yeah, I'll add there from an RNG perspective. There are certain feedstocks like dairy manure, poultry litter. Most manure feedstocks for RNG are actually considered carbon negative because they take more emissions out of the air than are put back in at the burner tip. So when you think of this, and it has to do with a lot of different pieces, is the manure lagooned before you build the facility, etc. But when you think of it, every day we're creating waste. That waste, whether it goes to a landfill, whether it goes to a lagoon, etc., it's just sitting there and it's emitting a much more potent greenhouse gas, which is methane. By us capturing it and essentially recycling it, we're able to create a carbon negative, carbon neutral fuel source. For renewable gas, we actually have to go through a very, very strict life cycle analysis where we have auditors come in, they do a life cycle analysis of all of our operations from every truck coming in to every truck leaving to how the manure is processed, et cetera. And they come up with a carbon intensity score. That carbon intensity score is used for a variety of things from pricing to valuing any tax credits, et cetera. So it's extremely strict. It requires a lot of internal work for us to make sure we're properly accounting for everything every day of operation. And so that's a really important component of our projects, and that carbon negative piece is really important from an accounting perspective. And that's something the federal government is actually working through as they think about various tax credits that have been created for biofuels, like the 45Z tax credit.
And nuclear power is, after it's constructed, carbon-free. And over the lifetime of the asset, when you include all maintenance and refueling, it is one of the lowest carbon footprints out of any energy source available.
Do you have anything that you want to say on decarbonization and hydro?
I mean, existing resources like hydro are sort of necessary in this decarbonization story, right? Like I said, it's harder to build from the electricity system side. It's getting harder to build new infrastructure. And so, relying on what we have here to deliver those, at least not moving backwards on some of these policy aims and these carbon intensity requirements. That's sort of key to the story right now for hydro.
Great, we're at 12 o'clock right now. A lot more questions, and like I said, we can jump into these at a future date. Want to thank all of you for not only bringing the content, but also being able to touch upon all these issues in such a limited time. We'll be sending a follow-up email to everybody who's registered with information about today's webinar, the recording, and any other links to information that the presenters might want to offer. If you're not already a Climate Work member, I'd love to have a conversation with each and every one of you about what your priorities are, activities, and whether there's anything that we can do to help your work. Thank you again. Enjoy the Friday and the weekend. It looks beautiful out there, and we appreciate your time and your expertise. Thank you.
Bye.